Hey, how's it going? Peter Stakem here. Want to make a quick video summarizing our last unit on radicals and square roots. First up, we've got simplifying radicals. My first example is radical 12, or root 12. The first step to simplifying a radical is thinking what perfect squares will go into this number. I know that if I multiply 2 times 6, I can get 12. But I also know that if I multiply 4 times 3, I can get 12. And 4 is on our perfect square list, so let's use that one. If I were to multiply radical 4 times radical 3, I'd get radical 12, or root 12. When I see radical 4, I know I could break it down. Radical 4 is the same thing as radical 2 times radical 2. When we multiply radical 2 by radical 2, it's almost like I'm squaring the number, or it's really multiplying it by itself. So in this case, since we're multiplying it by itself, the 2 could just come out. Since radical 3 can't be broken down any further, I could bring it down, and my final answer for radical 12, or root 12, would be 2 root 3. Next up, I've got radical 32, or root 32. So similar to this, we got to think about what do I have to multiply together to get 32? The first number that jumps out at me is multiplying 4 times 8. But there's another perfect square that's a little bit higher or greater than 4 that I could multiply to get to 32. If I use 16 times 2, I'll get to 32. So my first step, I've got radical 16 times radical 2, and that'll get me 32. Just like with radical 4, I could break down this radical 16. I know if I multiply radical 4 times radical 4, I'll get radical 16. I'm multiplying a root by the same number, root 4 times root 4. One of these 4's could come out. Radical 2 can't get broken down any further, so I can just bring it down, and my final answer for radical 32 is going to be 4. Next up, I've got radical 27. So first thing I'm thinking about, what perfect square could go into 27? I know 4 can't really make it, but 9 can, so let's try that out. I know that 9 times 3 will get me 27, so in my next step, I'm going to write root 9, or radical 9, multiplied by root 3, and I know that'll give me 27, root 27. This radical 9 can break down further. I know that if I multiply radical 3 times radical 3, I get radical 9. Now that I have a pair of 3's, or pair of root 3's, one of them could come outside of the radical. So I've got 3, and I'm going to bring this down and get root 3. So my final answer for root 27, radical 27, is 3 root 3, or 3 radical 48. Again, we're thinking what perfect squares could go into 48. I know if I were to do 4 times 12, I could get 48, but I think we could go with a higher perfect square number. Let's try out 16. If I were to do 16 times 3, I can get 48. So let's write that down. Radical 16 times radical 3 will give me 48. We could break down this 16 a little bit further. I know it's the same thing as radical 4 times radical 4. We got the pair. Let's get one of them out of the radical and bring down this root 3. So radical 48 could be simplified to 4 root 3, radical 216. So I gotta look at this perfect square list and think, what is the greatest number that goes into 216? My recommendation, try 216 divided by 4. You'll get 54. Try it by 9. You'll get a full number. 16 doesn't work. 25 doesn't work. 36 does work. And it's actually the highest perfect square that'll go into 216. If I multiply 36 times 6, I'll get 216. So I could break this down as radical 36 times radical 6. I know that 6 times 6 will give me 36. So I can break this down to radical 6 times radical 6. I've got my pair of the same radical. So 1 6 is going to come out. I can forget about these and bring down this other radical 6. I've got my final answer. So know what you're thinking. How am I supposed to remember that 36 will go into 216? Or any other number for that matter? And what if I choose a smaller perfect square than 36? I'll walk you through that right now. If I were to divide 216 divided by 4, I know that 54 is the answer. So 4 times 54 will get me 216. Everything's still under the root. I know radical 4 could break down nice and easy. It's the same thing as radical 2 times radical 2. Thinking about numbers that go into 54 that are a possible perfect square, 9 works out. And it would actually break down to root 9 times root 6. Root 9 breaks down, it's the same thing as root 3 times root 3. Now that I have a pair of root 2's and a pair of root 3's, one of these 2's could come out on the outside. One of those 3's could come out on the outside. And this root 6 is going to stay exactly how it is. I'm left with 2 times 3, root 6. Quick multiplication, and I get the same answer, 6 root 6.